Hi, I'm an old guy and I do maths, and here we have an interesting looking problem. We've been instructed to solve for x. Now, this is an exponential problem, but we don't go about it in quite the way that you're used to with other exponential problems. Our difficulty is that we've got some things in here that just make it really, really awkward. This 8, for instance. What do we do about that? What do we do about the fact that this is 2x and that this is x? Well, we apply a few rules. So let's get going. So we'll keep our 7. We're going to rewrite this as 7 to the x squared. We can split this up. This is 2 times x, and this rule here will give us 2 times x. So then we have 8 x, that's 7 minus 1. Okay. Maybe you can see where we're heading with this. What I'm going to do is I'm going to substitute 7x with a letter. I'm not going to use x. I can use any other letter of the alphabet because we've already got an x in here. So let's try z. We will make z equal 7 to the power of x. And then we can rewrite this as 7z squared, because we are squaring 7x, which we have agreed, or I have instructed, will equal z. And that is going to equal 8z minus 1. Does this remind you of anything? So let's rewrite this and see what it looks like. Remind you of anything? We've got ourselves a quadratic. And we just need to set about solving that, doing one or two other things, and we will have a solution to our problem. So the great thing about this is that 7 and 1 are prime numbers. So we can be pretty much assured that we can place 7z and z in each of these brackets on their own. Now, how do we get positive 1 and negative 8 out of that? And I should say, I think I said in this that 1 is a prime number. It's no longer considered a prime number, but back in the days of Euclid and Pythagoras, when I went to school, we were instructed that 1 was a prime number. And I've confirmed this with several elderly friends of mine who all had the same experience. It may have been linked to where we grew up or something like that. But anyway, 1 is not considered a prime number now. So if I said it was, my apologies. However, it only has 2 factors, 1 and itself. And so in this case, you can treat it as such. So we are going to have 1 and 1 in each of these brackets. And this is negative, so this is the set of factors for this quadratic. Okay, so what are the solutions for this? Well, z equals 1 over 7, that's just null factor law, and z equals 1, again, that's just null factor law. Now, you might think we're finished, but we're not, because I pretty much guarantee that if you put these numbers into this equation, you won't get very far. So what we have to do is we have to remember that we replaced 7x with z. So what we have here, if we bring back our 7x, 7x is equal to 1 over 7, and 7x is equal to 1. We have simple exponential problems to solve here. So just let me run through this again, how I got to here. So the first thing I did was to write out this in a form in which I got these two similar expressions, there and there. I then replaced 7x with a pronumeral. I chose z. If it's x, don't choose x, it gets confusing. What I noted then was that I basically had a quadratic. I factorized that quadratic and I solved it for z. And a lot of people would stop here, but you have to remember that z has replaced 7x, and so we have these two little exponential problems to solve, and that's pretty simple. 7 to the power of negative 1 is equal to 1 over 7, so x could be negative 1. 7 to the power of 0 is equal to 1, so x could equal 0. And these are our two solutions. You can put them back into this and test the idea, but I promise you it will work. So thank you very much for watching. I hope that this was useful. If you found it interesting or useful or both, please subscribe. There's plenty more where this came from in the playlists. See you next time. Bye.